Hello YouTube, I have a very exciting news. This is my first electronic videos I'm uploading to YouTube. As you may see, this is a bike turning signal. I found this on the 555-timer-circuit.com website. It is quite an interesting circuit to build. I'm giving them the credit to this website. But the only thing that they are sort of lacking is the PCB layout itself. For beginners, this might be a wee bit difficult. I have to mess around with a few PCBs and prove myself to get figured out. But that's what it actually looks like. You can actually modify the rate, how fast the lights actually flash and which directions they go. I'll see more about in a minute. But this basically actually runs on the 555 timer, and it uses BC547, but it modifies the transistors. They weren't working, overheating for me, because I'm using quite a high current. It's hooked up to the car at the moment, so it runs with 12 volts. Just few resistors. This is LEDs wired one into another, but I just decided to use one LED for this tutorial to figure it out. I'm using the program called Circuit Wizard to build this circuit. Show what it looks like in a second. This is the diagram I took it from here. What if I use this program to calculate all the circuits for me? It makes it absolutely huge, absolutely waste of a PCB space. So I decided I can shrink it really well and show what it looks like in real world right here. That was actually looks like. You have two capacitors. You can control the rate at how fast they flash. You can see them lights how quickly they flash. But you can actually, if you modify the value of them, say 500 microfarads, it'll be far slower. Like you can control the rate by them two capacitors. So I change back to 100. They both 100 microfarad capacitors. For them top LEDs, they're all 330 ohms. You can have any color LED you want. For them transistors, I'm using BC639, but you can use any NPN transistor if you wish. This is a diode I'm using, as in a circuit here. One here, and the other one in here. These two diodes I'm actually using. That's what it looks like. Another thing I want to point out is the PCB itself. I'll put in the PDF description so you can copy it from their own. This is the 555 timer chip, and this is the bridge in here. Bridge is the pin 4 to pin 8. So if you're going to build one, just make sure you put it in before you put the chip on top of that. Once by chip and soldered in, you have no access to the bridges. The only bridges in here. But then the rest of the resistors actually bend. Well, this is 10K. All of them is 10K for the bottom of the transistors, and they're 4.7K and 4.7K. I'll show you how they don't know. See what happened between pin 6, 7, 8. Resist 4.7 goes in this one and into this one, so you can drill two holes and they're kind of overlapping, and this is coming in here. So this looks like yeah, it's quite exciting. Actually, I want to show you how it's actually how you can vary this. This is the one's battery in here. What you can do is you can actually vary the directions they go in by changing the transistor or diode, or deleting it altogether. All I'm going to show you is it runs no problem at all this direction. But if you wanted to go if you want to go open, see to it goes to the end, disappears and starts from the beginning again. So you want to go in circles. What you simply do is just remove this diode right here. Just don't even bother putting it in the first place. And look what will happen now. So it goes in and back, in, over and back, over and back, over and back. So LED builder or anything you can call it. But another thing what you can do is by stopping this for a minute and changing diode's direction. It will go different direction. The lights itself will go different direction. It's blue open. Okay, I have to turn off the explosions. You can see going a different direction, but you have to vary the speed of the capacitors because it's not enough time for them to go back and forth. Just try to vary here. I was gonna experiment a little bit, and I found the best one. I think it was 420 microfarad for a top one, and for bottom was around 200 microfarad was the best value for them. I think that was the I think it is 200. If you want to go back and forth, yeah, it's 200 and 420 microfarad total. If you stop this for a second now. If you have diode actually go in different direction from like this way, and if you power a circuit, it will be going this way. Change back to 100 each because otherwise it will be too slow. This is what it looks like actually, and you can vary the voltage as well if you want. You go to variable voltage and just like 3 volts for example, and I'll show you how far you can go before it explodes. We'll take and then explode. You can just crank up the voltage a bit. As minus 12, just at 12 volts experimenting. Around 10 volts the last LED starts to light up very brightly. We can go a little bit higher and you can go to it explode at 13 volts. But if you use a higher diode, it will. If you use a voltage, higher rated voltage, and a diode won't explode. We'll keep going and see how far we can get before the chip blows up. You know, chips blows up around 16 volts. LED starts to blow up because the resistor not high enough. It's 17. Keep going further. Chip blew up and the LED blew up, and that's it. And really blows up since then. So if LEDs blew up and the chip blew up. So yeah, that's pretty much it. But the operation voltage for a chip is from 8 to, I think it's to 8 to 16 volts. So yeah, I will include the download link for the PCB artwork itself, so you can download it. See, you connect positive and negative in here, but what you can do yourself is add the kind of switch here and circuit if you wish, or something if you want. This is what it looks like on paved. There's more PCB design to see. There's a prototype board. That's what it actually looks like when it's kind of finished. The silk screen. This is for overlay if you wish to use that. I'll probably include that one as well in the description. And the components, just and this whole venue is really big into PCBs, includes that as well. It's a bit of a cough from soldering too much, and this is just the PCB artwork itself. Yes, I will export it and include in the description and include the dimensions. Thanks everyone for watching, and yeah, if you want, there's I'll include the link to the page. I got the circuit off anyways, and that's what it's gonna use over for. So yeah, so thanks for watching and have a good day.